Hello everyone, welcome back to MAT28. I'm sorry, this is MAT1100. Yes, we continue with section 3.6. In this section, we'll be talking about two new concepts. One is called proportion, and the other one we call that direct variation. Okay, so let's note it down. Section 3.6. Proportion and direct variation. Okay. So on the first part of our lecture, okay, I want to talk about proportion. Proportion. What is proportion? Let's go back to section 3.1. In section 3.1, this is the first time you are introduced to a term called ratio. And we learn how to set up ratio between two quantity, right? Two different quantity. And a ratio is nothing but fraction. And as you know, if we have fraction, we might simplify it or we may not. Okay, we might simplify it or we may not. If it is simplified, then we have another fraction equal to the original fraction, right? So if we have a fraction equal to another fraction, we call it proportion. All right. So proportion is two fractions equal each other. So if we have the first fraction is A over B, okay, and the second fraction is C over D. Okay, so we have two fractions and they equal each other. Okay, then this is proportion. Okay, so this is called proportion. All right, and this proportion is equivalent to A times D equal B times C. Okay. The equation I have here, the statement I have here, I don't know if you remember. Maybe you remember. You already learned in high school. This statement here, the way I do the multiplication, we call cross multiply. Okay, so this is proportion. Okay, and it's equivalent to this equation. Okay, the whole process we call cross multiplication. All right, so the whole thing over here, the whole thing here, oh, not good one. Draw it really nice. The whole thing here we call cross multiply property. Cross multiplying okay, property. Okay, because you see the A times D. You see A times D. You multiply it, right? Diagonally. Equal B times C. You multiply B by C diagonally. That's why we call it cross multiply property. Okay, and what we have here is proportion. Okay, so I'm gonna box proportion in red color. Okay. Okay, so this is proportion. Alright, this is proportion. You see that we have only two fractions. We don't have three fractions. We don't have four fractions. We have only two fractions, and between them is equal sign. Then we call it proportion. Okay. So I can say the proportion is nothing but two equal fractions. Okay, that is proportion. I can give you a quick example of proportion. Example. What if I have something like this? I have because proportion is nothing but equation, right? Equation, because you see that it's an equal sign here, and we know that equation contain variable x. Okay, so I can give you something like this. I can have x over 2 equal 4 over 5. This is the typical example of what proportion look like. Right, so this is a proportion. Right. And is this also equation? And because this is an equation, we can solve for variable x. Okay, how are we going to solve for variable x? We're going to apply cross multiply property. Okay, so this is a proportion, and now I can solve for variable x. So from cross multiply property, I can write, I multiply 5 by x diagonally, so 5 times x is equal to 2 times 8, right? By using cross multiplying property. Okay, then from here we can get the x, right? Because this is a linear equation. We already learned how to solve linear equation last time. 2 times 8 is 16, right? And in order to get the x, you divide both sides by 5, right? Okay, so x is equal to 16 over 5. Okay, some students ask me that, do we need to do division over here? No, you don't have to. Okay, you just go ahead and leave it like this. Okay, so this is a typical example of proportion, and the variable x here, it could be anywhere in the numerator and denominator. Okay, I can give you another example of proportion where x is in another position. For example, I have like 4 over 3 equal 2 over x. Okay, so this is also a proportion. And in order to solve for x, you're going to do the same thing. You will do cross multiply. Okay, or the variable x can be over here. It could be down here in the first denominator, so it could be x here, and 3 over here, and 7 over here, and 5 over here. Is this proportion? Yes. This is also proportion. Okay, this is also proportion. All right. Or a proportion, it could be a little bit more complicated. It could be something like this. It could be like x plus 2 over 5 equal 7 over 8, for example. Is this proportion? Yes. Okay. How do we know this is proportion? How do we know this is proportion? Very simple. Okay. You see that we have two fractions, right? We have two fractions, and between these two fractions is the equal sign. So as long as we have two fractions and between them is equal sign, it is proportion. Okay, so how are we going to solve for x in this proportion? We're going to apply the same thing. We're going to use cross multiply property. So from here, okay, I can do cross multiply. So I can multiply diagonally. So I multiply 8 by base x plus 2. Remember, you multiply by the sum. You must put the parentheses equal 5 times 7. 5 times 7. So from here, right, we're gonna do distribution. We already learned how to solve sub problem in previous section. Okay, so we're gonna do distribution. A times x, a times 2 is 16, equal 5 times 7 is 35, right? So from here, we're gonna subtract by 16, right? Remember? Okay, we already learned how to do that. So we can have ax equal to 29, right? 35 minus 16, and from here I can get the x. So x could be you divide both sides by 8, right? Because you want to get x by itself, right? So x could be 29 over 8. Okay, the 29 over 8, you don't have to change it to decimal number. You just leave it like that. If it can be simplified, then you should simplify. But this, you cannot simplify, so you can leave it like that. Okay, and again, if you have such proportion, the x could be anywhere. I could put a plus x over here and over here number 2. So x could be anywhere in numerator and denominator. Alright, and because you're in this level, you will see only one x. Okay, you're not gonna see more than one x. So don't worry, I'm not gonna give you something more than one x. Okay, if you have something more than one x, it's still proportion. Okay, example 5, for example like this. What if I have x minus 1 here over 4 equal 7x plus 2? It is proportion? Yes. But in order to solve for this proportion, can we use cross multiply property? Yes. But the thing that afterward, you don't know how to get the x. It at your level in this course. So I'm not gonna give you something like this, but I just want to show you that this is also proportion. Okay, this is also proportion. Alright. Alright, so that is the proportion look like. Now I want to give you more, because proportion is equation, right? That's why we can use proportion to solve word application problem. Okay, for example, something like this. So in example number, what example is that? Example number 6. I'm gonna give you word application problem. Okay, and we will use proportion to solve for this application. Okay, let's see. Let me pull up the example. Let's see. Hopefully, I got around here. There you go. I think I have enough right here. Okay. So I have a problem like this. Okay. Let's work on the problem together. Oh. Okay. Let's read the problem together. The book fair is this week. In this week, I think there's something wrong over here. There is a special deal for teacher. Okay. For every 5 hand cover books a teacher buys, he or she can get 2 paperback books. For every hardcover, she can get 2 paperback books. Okay, Miss Bowen is buying 35 hardcover for her classroom library. How many paperback books Miss Bowen will get for free? Alright, how are we gonna do this? Solution. How are we gonna do this? First of all, we need to know remember when I say ratio is fraction, and fraction is related to proportion, right? So we need to define the quantity, how many quantity we have in the problem. So the first quantity I can see here, we have two different quantity. The first quantity here is hardcover, right? It's hardcover, and the second quantity is paperback books. First one is hardcover books. So we have two quantity, only two. Okay. We have only two quantity. It means that we might be able to use proportion. Okay. Alright, so how are we gonna set up proportion? They asking you for the paperback. Okay, so I'm gonna call X represent paperback over here. So this is X here. This color is not good in white. So let me use red color. So I'm gonna call X represent paperbacks. Okay, represent what they asking you. Okay, then I'm gonna set up proportion. So we have 5 hardcover. So we're gonna do 5 hardcover. Okay. Okay. Over. Okay. Over 2 paperback. Okay. 5 hardcover over 2 paperback cover. Alright. So we have two different quantity. Then 5 and 2. So we're gonna have equal to, or you can do like this. You can do like this. I mean, this way work too, but I mean, maybe the other ways is better. So I'm gonna just go ahead and erase this. So I'm gonna put because the proportion is has two fractions, right? So I'm gonna put 5 hardcover here and 2 paperback here. Okay. Okay, Miss Bangwood is buying 35 hardcover. So hardcover, 35 hardcover will be go over here. Okay, because hardcover is going with hardcover. It corresponding to each other. Okay, how many paperback? So X is paperback, right? So it must go with paperback here. So X is here. Okay, X is there. So now what we have? We have a proportion. Just think about it. We cancel hardcover. Okay. All right. Cancel hardcover and X paperback here, right? So we cancel paperback. So what we have left is I'm gonna write over here a 5 over 35 equal to 2 over X, right? That's what we have, right? Okay. So in order to get X, which is the number of paperback books, we're going to apply cross multiply property. So we're going to multiply diagonally. So we have 5 times X equal to 2 times 35, which is 5 times X equal to 70, right? Then you divide both sides by 5, so you have 70 divided by 5, which is 12. And the unit will be 12 because X represents the paperback books. So 12 paperback books. Okay, so that's how you use the proportion to solve the word problem. All right. Okay, let's see. I can give you another one. Okay. Proportion is very useful. I can tell you that, very usual. So problem number 6. Number 6. Let's see, I can pull up another. Let's see. Okay. Let's see if I can pull up another one or not. Okay, let's see this one. Okay. 6. Alright. 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 So let's read the problem together. Answer. Again, right, we need to find the quantity. Find the quantity and what quantity they looking for. They asking, and we're gonna set up proportion. So the quantity they asking for is berry, right? Berry plaster, right? And we're gonna use we're gonna call X represent berry plaster, berry plaster. So this is X, right? This is your X. All right. So the first quantity is smoothie sack. And the second one is berry plaster. And we have 3 cup. Cup is the unit. Oh no. The best drink at no, smoothie sack is the name of the store. So the first quantity is berry plaster. Let me see. Okay, it takes 3 cups of strawberry to make 2 berry plaster. Okay, the smoothie sack has only 15 cups of strawberry. So the second property is strawberry. So the first thing is berry plaster. Okay. And the second one is cup of strawberry. Right? Alright. Now we can set it up. So 3 cups of strawberry. You know, as long as you're good, you don't have to write the way I am doing now. But because I consider you very new, so you're gonna write like this to make two of them, right? 2 different quantity, right? Cups of strawberry and berry plaster. So 2 berry plaster. Alright, 2 berry plaster. Alright, that's one of the how you set up proportion. And now we have what? We have 15 cup of strawberry left. So we have 15 cups of strawberry. Then they ask you for X berry plaster. So X represent the number of berry plaster we're looking for. So we're gonna cancel this, right? So you see that cup of strawberry go with cup of strawberry, berry plaster go with berry plaster. Okay, if you put 3 cups of strawberry here and you put X berry plaster here, that is really wrong. Okay, you shouldn't set a proportion that way. So after you cancel, my proportion will be 3 over 15 equal 2 over X. And from here I can solve for X by cross multiply property. Okay, so you have 3x equal 30 and x will be equal 10. 10 what? 10 berry plaster. Don't forget to put the unit in. Okay, 10 berry plaster. Okay. Okay, so that is how you use proportion to let me say I can come up with another one, but but this another one would be the same thing. Let me see. If I have it, I can put it up so that we can work together. Let's see. Hopefully I have. Look like we have another one here. Okay, but we don't have room. So let's jump to another page. Okay. Now, so example, I believe example 7, right? Let's see what is this. Okay. So this example 7. Okay, again, we find quantity, right? So let's read the problem to get a weight of an object on a very directly. Oh no, so this is not. I'm sorry. So this is not proportion. This is for the next concept. So I think that's all. So I'm gonna just go ahead and delete this. Let me see how I'm gonna delete this. Oh my god, I'm gonna delete this. Sorry guys. How am I gonna delete this? Okay. So yes, so that's all I have for proportion. That is how you use proportion to solve word application problem. Now we're gonna jump to the second part of our section. In this second part, we talk about direct variation. Direct variation is a concept to solve word application also. But what is direct variation? Alright, let's talk about its definition. What is direct variation? What do you think? What do you think? What do you think? Okay. Direct variation is actually a relation between two quantities. Okay, I can say the first quantity is x and the second quantity is y. And in this variation, the quantity y vary. Okay, the quantity y varies directly as x. Or can say another way of saying that is that quantity y is directly proportional to x. That's what means by direct variation. Okay, so I'm gonna just go ahead and write down that. Okay, so direct variation, okay, is a relation between, okay, quantity y and quantity x. Okay, where y varies directly with x. Another way of saying is that in other word, y is directly proportional to x. You know, every time you see that, you see the word proportional, right? It means that's something related to proportion, something related to the first part of our lecture. It means that in direct variation equation, which is I'm going to give you now, you can use proportion concept cross multiplying property to solve for the k value. Okay, the k value is nothing but a constant real number. It's called a constant variation. So the direct variation equation is y equal to kx. So this is direct variation equation. Okay, and k in this case is called constant of variation. Okay, and this is direct variation equation. Alright, direct variation equation. Do we have indirect variation equation? Yes, we do. Yes, we do. In this case, in that case, the constant k is under the denominator. But in this course, we don't cover indirect variation. We just need to cover direct variation when you go to college algebra. Yes, we will cover indirect variation. Okay, and you will if you go into college algebra in that course, it's not just a relation between two variables. You can have direct variation between three variables. Okay, but in this course we just cover direct variation for two variables. Okay, now we can jump to example right away. And how we're gonna use this equation to solve word application problem. Example. Alright, let me see. I can pull this example. We did this last time. We pulled one of them, right? Look like we pulled the wrong one. Look like that is direct variation. Okay, right here. Alright, so this is the direct variation problem. You see that? If you read the problem, the weight of an object on Earth, okay, vary directly as the weight of the same object on the moon. Okay, if a 300 pounds object would weigh 45 pounds on the moon, okay, how much 65 pounds object weigh on the moon? Okay, so how we do this? Solution. How we gonna do this? Let's see. Okay, we're gonna use this equation, but we need to know which is y, which is x. Well, we have two quantities over here. So I can say that the first quantity must be the weight of the object on Earth, and the second quantity is the weight of the object on the moon. Okay, it doesn't matter which one is y, which one is x, because it's y and x. It's just a variable, just a name. Okay, they're asking you how much would the 65 pound of weight of the object weight on the moon. How much would a 65 pound object weight on the moon? Alright. So they give you 300 pound object would weigh 45 pound on the moon. It means that this 300 pound over here is on Earth. This is on Earth. So this is on Earth. 365 is on Earth. They give you 45 on the moon, and they ask you for the one of the variable here on the moon. Okay. So in order to do this, because it's very directly, let's say very directly, I'm gonna just go ahead and share that the important information here. Okay, it's very important. Okay. Very directly. It means we have to use it. Okay. But in order to use this, we need to get the K. Okay. We need to get a K. In order to solve this, we need to get direct variation equation first. Okay. But in order to get direct variation equation, we need to get the K. Okay. What is the K? Okay. So I'm gonna say Y. Let me use different color. I'm gonna say Y represent the weight on Earth, and X represent weight on the moon. Okay. Then the equation, the direct variation equation will be, okay, from this I can get direct variation equation formula y equal to kx. But this is just a formula. This is just a formula. Our goal is to get k. Okay, as long as we get k, then we can get an equation. But how are we gonna get k? We're gonna use the information they give us. So 348. So 300 is the weight on Earth. So we're gonna do 300 here. You replace that with for y, and k here, and you replace 48 for x. Right. And from here you can get k is 300 divided by 48. 300 divided by 48 will be what? Let me get the calculator. 300 divided by 48. Okay. Hold on. Okay, so 300 divided by 48, we will have 6.25. Okay, 6.25. Okay, so that is k, and from the k I can get the direct variation equation will be y equal to 6.25 times x. So this is the direct variation equation. We just got the equation. Okay. Now we're gonna get this answer. The question right here. How much would 65? So this is I'm gonna put over here just in case somebody forget what it is. So this is the direct variation equation. Okay. Question is, how much would 65-pound object will weigh on the moon? Immediately asking you on the moon, they give you 65 on Earth. It means they give you the y. So our job is to replace y here with 65. So it will be 65 equal to 6.25 x, right? Because x is the weight on the moon. That's what they're asking you. So from here, I can get x is 65 divided by 6.25. Then let's do a quick division here. Then it will be 10.4 pound. which is make really sense because on the moon, then any object seems to be lighter. You see, 300 pounds and it just weight 48 on the moon, 65 pounds, so it should be only 10.4, which is good. 10.4 pounds, so it's kind of lighter on the moon. Okay, 10.4 pounds. All right, on the moon. So that is how you use direct variation to solve the problem, the word problem. Now, example 2. Let's see. I can pull up example 2. So this will let's do 4. Let's see what happened here. Okay, is this the yes? This is direct variation problem. Okay, you see that, right? Okay. Alright, so again we're gonna use the same strategy. Okay, we're gonna determine the quantity, the distance required to stop a car very directly as the square of the speed. Okay, distance required to stop a car very directly as the square of the speed. So the first quantity, it must be distant. Okay, must be distant. And the second quantity must be speed. Okay. And how many bits required? So they're asking you for feet. It means they're asking you for distance. So it depends on which one is y, which one is x. So if you see last problem, we say that y direct because they say the weight on Earth very directly with the weight on the moon. So y could be y. So the same thing over here because this one very directly with the speed. So y, okay, y will be distance. Okay, then x will be speed. Maybe in this problem I just want you to set up the direct variation equation only because this is related to square and maybe some of you have not learned this and we never talk about how to solve the equation with square. So in this problem I just go through how to set up direct variation equation. Okay, so the direct variation equation would be y equal to kx. Okay, our job is to get k. In order to get k, how are we gonna get k? Okay, right here they give us. So if 250 feet are required to stop a car traveling 60 miles per hour. Oh, you have to be careful over here. So first of all, this is feet, but this is miles per hour. Okay, so you have to convert this to miles. We have to convert this to miles. Okay, so how are we going to convert this to miles? What is the relation between feet and miles? Anyone remember? I don't remember either. I believe that last time we talked about that, right? In section, let's go back to section. What section we learned when we do unit conversion? Anyone remember? me see. Oh my god, back in the day it's 2.3. Let me see, I can go back to 2.3 or not. Let me see. 2.3 is kind of very far away, because we need to get the relation. On the test, of course, I'm going to give you the relation. 2.3. Let me see, I can get all the way back to 2.3 or not. Okay. I mean, I can look it up, but I don't have the phone right over here. Oh, I think right over here, right? No. Let me see. Is that 2.3? Miles and feet. We need to know that relation. 2.3. Yes, 2.3. So we had to go all the way back. Let's see. It's the 3.1. Maybe I don't keep it over here either. 2.6, 2.5. Oh, right over here. Okay, so unit. Let me see. We have any feet to miles. We have feet is 12 inch. Nope, we don't have it. It means that we need to look it up on internet. Let me see. How about here? Maybe I have it here. Here you go. Right here. 1 mass is 5280 feet. Alright. 1 mass is 520. Remember, okay? 5280 feet. Okay, so let's go. 5280. Okay. 5280. Let's go all the way to 5280. Okay. Alright. Just take a little bit of time. Alright, so 1 mass is 5280 feet. Now we need to change 250 feet to miles. Alright, so we're gonna set up, right, ratio, right? The rate, 1 miles is the conversion unit factor, right? 5280 feet. Okay, you multiply by I think we set up the other way because we need to keep the mouse. So we're gonna have 250. Yes, we're gonna keep them at 250 feet here. Okay. Right. Over what? Okay. Over 1. Right. Okay. So this is equal to what? Feet cancel. Alright. Let me check one more time I set it up right or not. Yes. So over here, I will have 250 divided by, right? 250 divided by 5280. Alright, your answer will be 0.0. 473 miles. Not a nice number, but that's what it is. Then we have to keep it that way. Okay. So it means what? It means that 250 feet will be 0.0047 miles. Okay. So we're gonna put over here, instead of put 250 feet, we're gonna put 0.00473 to replace for y equal to k. Okay. Direct. I think I set it up the equation wrong. Very directly as the square of x. So this is square of x. Okay. Okay. So it's a little bit from last time. Last time it just you see that last time is very directly as the weight is no square. It's no square. This is square. That's so square of the speed. So this square of the squares the second quantity equal to x is the speed. So x will be the speed will be 60 miles. Will be 60 square. So give 1,00473. From here I can get k. 60 square is 3600. So from here I can get k is 0.047 divided by 3600. Then my k, oh my god, my k is really bad. My k is 0.000013. Not a nice number at all. Not a nice number at all. Let me check one more time. Then let make sure that we got everything right. Because as long as I got the k right, I can get the equation. So y, the equation will be direct variance. The equation will be y equal to 0.000013 x squared. But let me check one more time. Let's check together, okay? If we got them right, because I'm a human. I may have human error too. Okay, let's read it again. Distance require the stock very directly the square of its speed. Okay, with 200 feet are required to stop a car traveling 60 miles per hour. So we give 60 miles per hour. How many feet required to stop a car at 90 miles per hour? Oh, okay. Okay. So we're gonna do one more step. I think we can do one more step. Okay, so let me check the unit conversion. So 1 mile is 580 feet. Is we have 250 feet. So will be division. So 250 divided by the feet. Yes, it should be good. All right, let's continue. All right. Look like that we can solve this problem. Look like that we can solve this the question here. Okay, because at the beginning I thought that we just need to set up the direct variation equation, but look like we can solve for the distance, because the feet, it means you can solve for y, and they give you 96 miles right here. So over here, your y, so at okay, I'm gonna just space over here. So at 96 miles per hour, the distance will be y equal 1,0000013 times 96. You plug it in into this, okay, square. All right, multiply by 96 square. All right, then your answer will be 11212 miles. Oh, there you go. Alright, so then this one is direct variation equation. Okay. Alright, so that's the second example. Let's see, I can pull up another example or not. Okay. Alright, let's see. Example number 3. Which is that this one? 4, 5, maybe this one. There you go. Okay. Alright. Okay. So example number 3. Alright. Let's do that. Okay, first of all, let's define the quantity. The number of brick laid direct, so the number of brick is the first quantity. Very directly with amount of time is the second one. And I'm gonna call determine the time. It means this is the x right here. Alright. Oh, this is easier than the second one. Is I think this we can do really fast. So we have y as the number of brick and x as time. So from here I can set up this y equal to kx, and we need to get k to get the direct variation equation. So you have 45 equal k, x is 60 minutes. Okay, that's okay. We can use minute. So 65 minutes. If they ask you determine the time in hour, then you have to change. But this is a minute, so you can get k is 45 over 65, which is 0.692. And from here I can get the direct variation equation will be y equal to 0.692x. This is direct variation equation. Now determine the x, the time to take to lay 500 bricks. So add 500 brick. Okay, so we put 500 into the equation, 0.692x. So x will be the amount of time they're looking for. 692. So 500 divided by that. So will be 722 minutes. Alright, this problem is easy. So much easier. Okay. Alright. So that is how we use direct variation equation to solve a word application problem. Again, I'm going to give you something like this on the test, and it's very important concept because as I already said in the first day of our course, and I say that in this course this is foundation, and it's a little bit different from the traditional one because we deal with more application and we deal with more data, numerical data analysis. So please focus on doing word application problem. How? You just do a lot of problem, and as long as you do a lot of problem, you will feel confident in yourself, then everything will be okay. Alright, I think that's all for this video section 3.6. I will be seeing you next time in section 3.7. Bye bye.